Tonight we're going to try and put all the wiring together and actually get probably right up to where we can actually start to program this. So far, if we have our Raspberry Pi and we kind of zoom in on the pins here, what we're going to do is use pins 9, 11, 13, and 17 to drive the A4988. And technically this is a driver. I keep saying that and it doesn't make any sense. We're going to use this to control the driver. How about that? So on the driver, the A4988, we've already talked about this. We're going to jump these two together. This is on by default, so we're going to leave that alone. V motor, we're going to connect with a 100 microfarad capacitor in between. So coil 2 and coil 1. And then this is going to go to the Raspberry Pi, and these are going to go to the Raspberry Pi. So this is the power coming from the Pi to the driver. This power coming in here is going to come from an external source. This power from the Raspberry Pi is going to be 3.3. It's going to be the step pulse, sends a pulse, motor steps. This is going to control the direction. This is the regulator. So we're going to also set this so that it's only allowing 1.2 volts. I do not understand this in the slightest, but we need 1.5 amps to drive. And so in order to determine what voltage should be allowed through here, we have to calculate the voltage reference by multiplying the current times 8 times the resistance. This is R cents. I have no clue. Just none. Our sense is in ohms, and you determine the ohms or the resistance that you're working with by looking at the capacitors that are mounted to the board. In this case, each one of these capacitors, there's 2 of them, one for each coil, 0.1 ohms. So 0.1 times 8 times 1.5 is 1.2 volts. We're going to do red for VDD. Always want to make sure you get that second D in there, otherwise it's just VD. Black, negative for ground. Ground is going to be pin 9. I don't know why. That's just the way I picked it. So 1, 3, 5, 7, 9. The VDD is going to be 17, so 11, 13, 15, 17. So obviously this should be negative, or it shouldn't be anything right now. Yep, okay, good. All right, so this is the screw that we're going to adjust, and then there's the ground. Okay, so once we get power going through the Raspberry Pi, the Pi is now supplying power, and this is 0.233 volts. That can't be right. Am I doing this wrong? We don't know what we're doing. Okay, as per usual, we got this wrong. All right, so there are new or old versions of the A4988s. And apparently there's a new style that doesn't go up to 1.2 volts. It only goes up to, I think I got it up to 0.79 before I got nothing, which I assume means I destroyed it. Be that as it may. These new style, it's a different calculation, so it's 1.5 amps for the NEMA 17, just like before. But you do a 0.54 factor, which is supposed to correlate to the new R100 sense resistors, which are 0.068 ohms. And that gives you a 0.81 volt. To be on the safe side, since I've already fried one, I'm going to go 0.7 volt. And as you can see, I have a new one, and it's got a nice little heat sink there, because yeah, that was fun. All right, there, 0.69. We're gonna leave that alone just for the meme. Okay, so that goes back in there. Okay. Short little coda here. Something's wrong. Haven't figured it out yet. Gotta go to bed though. Got work in the morning. Basically what's going on right now is I've got the code in, which was easier than I thought it'd be. Went ahead and connected the power. And when I first plugged it in, it made a little noise, which was alarming. And when I would go to run the code, nothing would happen. And I wanted to see if this was getting warm. Went ahead and touched that, and it turns out if you touch it, this vibrates. But it's a vibration. It is not turning. It is not happy with whatever's going on. It is working. I don't know what I did. I don't know how I did it, but we have everything connected. This is more for my benefit than poor souls who are watching this crap. Purple is the direction. Gray is the step. We've got sleep, reset, jumped. The half steps, quarter steps, and the, what's the third one? Oh, I guess we've got full, half, quarter, eighth, 16th. The micro step modes, not connected. Neither is enable. On this side, we've got the 100 microfarad in between the 12 volt and the power to VMOT and ground. We've got coil 1 in red going to 2B, 2A. Coil 2 in orange going to coil 1A, 1B. And then we have power from the Raspberry Pi, going through 0.1 microfarad ceramic capacitor. So that is working, and we've got just a really crude code. As we get more sophisticated here, we're going to add, as you'll see, we're definitely going to have to add the micro step. So we've got the pin assignment, we've got how many steps per revolution. The idea here is that it's going to spin clockwise and then it's going to spin counterclockwise. So let's see that happen. Yeah, we're gonna have to do a little work to make that actually usable. But hey, it is working, so that is a huge plus. Halla, blank and luya. All right, well.